Hello everyone, I am Swati Jagadishan, studying first MSc Microbiology at Vivekananda Arts and Science College for Women, Sangagiri. This presentation was prepared under the guidance Dr. R. Dinesh Kumar Sir, Assistant Professor, Department of Microbiology. Subject Bioremediation, and my topic is Dechlorination. First I speak about dechlorination. Dechlorination is process of removing or neutralized reduced chlorine and chlorinamide from treated water before it used or discharged into the environment. Why used chlorine? Chlorine is widely used in water treatment. First, it kills disease causing microorganisms. Chlorine destroys the bacteria, virus, and parasite present in water. Second, it prevents the waterborne disease. By disinfecting water, it helps to control the disease such as cholera and typhoid. Third one is it fast and highly effective. Chlorine acts quickly compared to the many other disinfection. Fourth, it economically easy to apply. This chemical easily available and suitable for both small and large water treatment plants. It widely accepted for public. Need for dechlorination. First, protect the aquatic life. Chlorine is toxic to fish and other aquatic organisms. The dechlorination prevents the aquatic life. Second, prevent the damage to biological treatment system. The reduced chlorine can kill the beneficial microorganism in biological wastewater treatment unit. The dechlorination help to maintain the proper microbial activity. Third, compliance and environmental regulation. Many discussed stands limit the chlorine reducer. The dechlorination ensure the treated water. Fourth one, reducing corrosion in pipelines and equipment. Chlorine can corrode metal pipes and equipment. Removing the chlorine and extend the lifespan of infrastructure. Fifth, improving the taste and odor of water. Chlorine can cause unpleasant taste and smell. The dechlorination enhances the accessibility of drinking and the process of water. 6. Prevent the formation of harmful byproduct. Chlorine can react with the organic matter from the toxic disinfection byproducts like trihalomethanes. The dechlorination process minimizes this risk. Methods of dechlorination process. Dechlorination process follow the three methods. First, chemical dechlorination process, physical dechlorination process, and biological dechlorination process. First method, chemical dechlorination process. Chemical dechlorination is the process of removing free chlorine and chloramine from water by adding a suitable reducing chemical. The chemical dechlorination process main aim to make a water safety, food processing unit, beverage manufacturing, laboratory uses and biological treatment units. Chemical dechlorination process mainly used following these chemicals. First, sodium bisulfate, sodium metabisulfate. Next, sodium thiosulfate. Third, sulfur dioxide. Fourth, ascorbic acid. Sodium bisulfate. These chemicals reduce the chlorine to chloride and form the sulfate product. The process of sodium bisulfate. Chlorine concentration is analyzed. A dosing pump inject the bisulfate solution into the biplane. Next, flash mixture ensure the uniformly mixing. Collect the dechlorination water and analyze the confirm the zero reducer chlorine. This process is very effective, widely used in food industries, beverage plants, and RO feed water systems. Sodium thiosulfate is a strong reducing agent. It converts the chlorine into harmless chloride ions. The process of this method: measure the reduced chlorine in water, prepare the dosage in sodium thiosulfate in solution, add the solution in the water tanks or line, rapidly mix and contact with the 1 or 2 minutes. Check the reducer chlorine. Features of this method: very fast reaction, highly effective for free chlorine, widely used in laboratory and food industries. Sulfur dioxide dissolved in water to form a sulfurous acid which reduces the chlorine. The process of sulfur dioxide. Sulfur dioxide is a gas stored in cylinders. The gas injected into water truly as a diffuser. The rapid mixing is provided. The dechlorination water is discharged. Advantage of sulfur dioxide process. It economically large plants for using very fast reaction. Ascorbic acid is a mild reducing agent that converts the chlorine into chloride. The reaction of a ascorbic acid plus chlorine, the convert in the dihydroascorbic acid and chlorine. Advantage of this method: food grade chemicals and safe for drinking water and food application. Chemical dechlorination process. First, chlorine is analyzed. Chemical dosing: thiosulfate, bisulfate, sodium dioxide, and ascorbic acid. Next, rapidly mix. Contact time, reducing chlorine test, and finally convert to the dechlorinating water. Second one is physical methods of dechlorination. Physical methods mean removal of a chlorine from water without adding the chemical. The chlorine remove mainly the physical absorption and physical mass transfer. Activated carbon dechlorination has a very large internal surface area. When chlorinated water passes through it, the chlorine molecules are absorbed and also reduced on the carbon surface. So, chlorine is converted mainly into the chloride ion. This is called cat-like reducing on carbon. Aeration method. The free chlorine is volatile. When water brew into the close contact with the air, the dissolved chlorine escape into the air. The chlorine concentration reduces in the water. This is a physical mass transfer process. Third one is biological dechlorination process. Biological dechlorination process is removal of chlorine or chlorinated compound from water by the activity of microorganisms, which is chlorine containing compounds as part of the metabolic process. Unlike the chemical dechlorination, no reducing the chemicals are added. Instead, the living microbes carried out the reactions. Reactive dechlorination. This is your most important biological pathway. The mechanism of reactive dechlorination. Under anaerobic condition, some bacteria use the chlorinated compound as an electron acceptor. This chlorine atoms is removed and replaced by hydrogen. Role of microorganism. Microorganism attached to the polluted water or biofilm produce the special enzyme, break the carbon to chlorine bonds, release the chloride ion into water. Biological dechlorination process. First, influent water or wastewater. The reducer chlorinated compound some slow level from chloroamine and chlorine. Second, biological reactors: anaerobic bioreactor, biological filter, biofilm reactor, and natural biological treatment zones are involved. Third, the microbial action. The microorganism using the organic substrate as food, electrons are released, the chlorinated compound are reduced, and removal of the chlorine. Fourth step, conversion. The chlorine compound, the particularly dechlorinated compound, the finally non-dechlorinated compound convert the chloride ions. Treat with water outlet. The glychlorination and detoxified water leave in the system. Advantage of dechlorination: remove the toxic chlorine from water, protect the aquatic life and aquatic life forms, improve the water quality essential for wastewater discharging, prevent the formation of harmful byproduct. It can be applied at the extrude and institute level. Advantage of dechlorination process: operation complexity, risk of incomplete dechlorination, chemical handling to make hazardous, produce a secondary byproduct. The biological method are very slow. Thank you for watching this video.